Okay, so we are gonna solve a percent problem in this video. I'm gonna do it a couple ways in this same video. So I think the main thing when solving word problems is that you really just need to figure out what's being asked, what information you know, and how you can use that information you know to solve the problem. So here we have Kennedy has 14 cats. That's a lot of cats. 3 of her cats are kittens. What percent of her cats are kittens? So, what are we being asked? First of all, we're being asked what percent of her cats are kittens. But there's no percents in this problem, so how do we figure it out? Well, we're going to try to use information that we know to figure it out. So we know that Kennedy has 14 cats. And we know that 3 of them are kittens. So we know that she has 14 cats and she has 3 kittens. Now that's not 14 cats plus 3 kittens. 3 of her cats are kittens. So what percent of her cats are kittens? Okay, well, still, how do I do that? I can first, because I know that percents and fractions and decimals can all be turned into one another. So I know that a percents can also be fractions and decimals. I guess I should make that a capital letter, huh? Don't want to upset your English teacher. Put a period. Percents can also be fractions and decimals. Well, with this information that we have, I know that I can turn this into a fraction pretty easily. So 14 cats is what she has all together. She has 14 cats all together. So I know that when I write a fraction, I write it as a part to whole. And I know that the whole number of cats, all of her cats, she has 14 cats. And I know that part of her cats are kittens. So some of them are kittens. 3 of them are kittens. So now I have represented Kennedy's cats as a fraction. Now, I can also turn a fraction into a percent by turning it into a decimal first. That's one way to do it. So we're going to do that way first. So I'm going to turn the fraction 3/14 into a decimal. Now we've gone over this before, and what I always tell you guys is that all fractions are division problems. So since all fractions are division problems, I can divide 3 divided by 14 and get a decimal. So I really want you guys to remember that all fractions are division problems, because sometimes you might be doing a problem and you might see a fraction and you go, I don't know what to do with that fraction, and it might just be helpful to turn it into a decimal. And you do that by dividing top divided by the bottom, top number in the house. 3 divided by 14. Top number in the house. Okay, so now we have 14 into 3, and 14 doesn't fit into 3. So what do? Well, I've been telling you guys that if it doesn't fit, then you can add a decimal. That's still 3. And then add 3 zeros. And that's just one of the ways that I've been teaching you guys how to do the division. So now I have 14 into 3,000. If you know the decimal's still there, but you can kind of ignore it while you do the division. So the first thing, I'm just going to make sure that I bring my decimal up here into my answer. And I'm just going to do this, the division the traditional way. So 14, and you don't have to do it the traditional way. If you like doing it the box method or any of the other ways, you can do it that way too. But I'm going to do it the traditional way. So 14 fits into 3, no times. We already decided that. 14 fits into 30 twice. So 14 times 2 is 28. So 28, 2 goes up here. 14 times 2 is 28. I already did that. Okay, and then subtract, and then we keep going. Bring down the 0. And then 14 goes into 20 once. Okay, and then 1 times 4 is 14. Sorry, 1 times 14 is 14. And then we subtract again. Get 6 and bring down that last 0. And 14 into 60 4 times. So it went into 30 twice. So 14 times 4. 56. Okay, so 4 times is right. And then you end up with a 4 at the bottom. So I have been telling you guys that when you're dividing and you have a decimal, the reason why we add 3 zeros just in the beginning is because really it's enough to go 3 digits past the decimal. At least for my class it is. So now that you have 3 digits past the decimal, you have 0.214. It's enough. You've done enough dividing. You could probably divide forever and never end this problem if you kept on going forever and ever. We're not going to do that because that's no life to live. Doing a division problem for your whole life, you might get kind of bored. So we don't do anything with the 4. It's left over, but it's not really a remainder because you can just use the decimal. So we're going to say that our decimal is, it's another color, I got so many, 0.21. Because I always tell you guys to round to the nearest hundredth, and since the 1 is in the hundredths place, we look to the 4 to figure out what we should make the 1. So we kind of look at it like this. We go, okay, well, the 14, is that closer to 10 or is that closer to 20? And it's closer to 10, so we leave that as a 1. So 0.21. You could write 0.214, and I'm not going to mark it wrong, but I do want you guys to try to get into the habit of rounding to the nearest hundredth. So when you have a decimal, now percents can also be fractions and decimals. Now, once you have your decimal from your fraction, then turning it into a percent is pretty simple. All you need to do is move the decimal over. So you move the decimal over 2 times to the right. 1, 2. And it ends up being right there. So you get 21%. And that's an approximation. So you could say approximately 0.21, approximately, a little approximately sign looks like waves, 21%. So about 21% of Kennedy's cats are cute. Just kidding. Kittens. They're probably all cute. Okay. So I'm not going to stop the video there. I'm going to show you how to do this exact same problem using a proportion. So when you have percents, when you're trying to figure out percents, you know that they're all out of 100. So here we can do the kind of the same in the beginning where we said, okay, Kennedy has 14 cats, 3 of them are kittens. Okay, so she said 14 cats, 3 are kittens. That's the information that we know. Now, when we use proportions to solve a percent, we do it a little bit differently, but you're still doing division. So it's pretty similar. But I want to remind you what a proportion is. A proportion is two equal ratios or two equal fractions. So we're going to create a proportion with this problem. So just like we did in the other one, if I could like go back and forth, just like I did here, where I did the part to whole equals 3 to 14, I'm going to do the same thing here. So I'm going to say my part, and that's like the main part of this, is putting together your proportion. So I have a part, and I have a whole, and my part is 3, and my whole amount is 14. So that's part of her kittens, or part of her cats, and that's all of her cats, including the kittens. And now that is equal to, this is where the proportion comes in, okay? So if you think about the whole, the part is 3, the whole is 14. 14 represents all of her cats, which also can be said as 100% of her cats. So the whole is 100%. One whole is 100%. And one whole in this case is 14 cats. So I can say that 14 cats is equal to 100%. And I'm just writing 100. I don't need to write percent. Just 100, because this is going to be our percent. All percents are out of 100. So that becomes our unknown. We're going to use a variable. So this is also an introduction to a little bit of algebra, which we're going to be working on a little bit later in the year. So part to whole, 3 to 14, x to 100, because we're trying to figure out our percent. So basically you've taken the basic information, part to whole, as numbers, and now we're turning it into a percent. We're bypassing the decimal, basically. So it doesn't necessarily mean it's easier or better, it's just a different way to do it. So now we have a proportion and we have to solve for x. Now you've seen this before. Let's do an example where you have like, okay, we have 1/2 is equal to what number over 100, right? And you can say, oh, well, I know that I could just say 2 times 50 equals 100. Well, 2 times 50 equals 100. So if 2 times 50 equals 100, I have to multiply the top by 52, and then that's 50. So that ends up being your answer right there is 50. But in this situation, it's not that nice. You can't just say 14 times something equals 100, because 14 times something like a whole number doesn't equal 100. It's going to be a decimal. So we're going to do it a slightly different way. And so we're going to use something called cross multiplication. Cross multiply. And cross multiplying is when you multiply the values or the digits that are across from each other. So you have 14 is across the way from x, and 3 is across from 100. And the way it works is that those cross products, or those things that are being multiplied together, are equal to the other cross product. So 3 times 100 is equal to 14 times x, which you just write as 14x. This is just the way that you write it in algebra. You wouldn't write 14 with a multiplication symbol in between the x and the 14, because then it would just look like 14xx. So you just write it with the variable next to the 14. So for this right here, this whole thing right here means 14 times x. Okay, so we're going to keep on going. So 3 times 100 is 300. If I did it over here on the side, with 3 times 0, 0, 0, 3, okay, is equal to 14x. Okay? Now, this is where you're using a little bit of algebra skills to figure out what x is, which you need to do. So we have 14 times x equals 300, which is the same as saying 14 times something equals 300, which also means 300 divided by that something equals 14, or 300 divided by 14 equals something. So it's kind of like a fact family, like where you have like 14 times x equals 300, and then 300 divided by 14 equals x. I remember those like fact family triangles or something. Anyway, that's not my favorite thing. So, but basically 300 divided by 14 equals x. 300 divided by x equals 14. 14 times x equals 300. And you could also even say x times 14 equals 300. And when you look at this written out, you can kind of see why we don't put an x in between, or a multiplication sign in between the x, because it just looks like two x's. If you look at this whole thing in a simpler form, so like if you think of it as an easier math problem, you could do, let's just say you have 5 equals 2. It's a bad example. How about 50 equals 2x? So you would ask yourself, okay, 2 times what? 2 times what equals 50? And you might just know, okay, well, 2 times 25 equals 50. But you can also figure out that 25 by dividing. So 50 divided by 2 equals 25. Okay, so that really, some of you just know that math, but in this case you might not know 14 times what equals 300, because it's not a super simple number. So what we do is since 14 is being multiplied by x, we do the opposite of multiplication, which is division. So we're going to do 14 divided by x. I'm going to write it like this. I'm sorry, not divided by x. 14x divided by 14, and 300 divided by 14. Now this is a whole lot of lesson all in one thing. So 14 is being multiplied by x, so we do the opposite, which is division. And if you notice, I wrote it like a fraction, because I've been telling you guys all along, all fractions are division problems. And so in algebra, this is how you write it. This is 14 divided by 14, and this is 300 divided by 14. The reason I do it on both sides of the equal sign is because these are supposed to be equal. If I do one thing to this side, I have to do it to the other side so that they stay equal. They have to stay equal, or I mess up all of them. Then they wouldn't be equal anymore and it wouldn't work. So now I have 300 divided by 14. 300 divided by 14 equals 1x. So 14 divided by 14 is 1, because anything divided by itself is 1, which would equal 1x. And 1x is really just x, because 1 times anything is whatever that thing is. So now I have this. You could say that, okay, x equals 300 over 14, and she has 314% kittens, but I probably wouldn't accept that, so we have to actually do the math. So now we're doing 300 divided by 14, top number in the house. 300 divided by 14. If you look at our other work, it looks very similar, where you had 3 divided by 14. And now we just already have 300 divided by 14. So we kind of already know what the math is. We know that 14 went in once. Sorry, twice. This video is really long. I'm starting to lose my mind. And then 2. And then 0. And then 14 goes into 21 time. Okay, and then times 14. And 6. And now I want to keep going because I'm not just going to write that my percent is 21 remainder 6. Nobody writes percents that way. So I'm going to add a decimal like I did before and bring it down. And 14 goes into 60. We decided that on the other page. Yeah, it was 4. So bring your decimal up here, 4. So I know I always tell you guys to go 3 digits past the decimal, but since we're figuring out a percent here, it's okay to round percents to the nearest percent. So this is our x. 21.4 equals x. And since we're rounding it to the nearest percent, it ends up being 21%. So 21% of Kennedy's cats, I'm running out of room, are cute. I mean kittens. Are kittens. They're all cute, right? So 21% of Kenny's cats are kittens. So that is, almost 22 minutes for one problem. So this just shows you how different things can be done to get 21, same answer. Okay? Yeah, goodbye.